Okay, so what we're going to do now is we're going to try and do an experiment, and in this experiment we are going to attempt to see if we cannot maybe plot a graph of how the capacitor charges and discharges. And you'll recall from the theory that charging and discharging process is an exponential waveform, and so we are going to connect a battery, which I have over here, and we're going to connect it to that to the capacitor. You'll see that I have a 100 microfarad capacitor over here. I know it looks upside down, but it's actually the right way around, and I can say that because I can see that the positive terminal of the plate is on the left hand side where the positive terminal of the battery is, and there's the negative terminal of the battery. So this circuit is not yet completed. I think you can ignore these two connectors for now, because I will be using them to discharge the capacitor at a later stage. And you can also see that I've got some measuring points over here. Now, the important thing is, in order to be able to plot the exponential charge and discharge of the capacitor as a function of time, we cannot do that with a multimeter, because the multimeter only gives us a value at each time increment, and in fact it averages the value over a certain time step. So the multimeter can provide us an indication that the capacitor is indeed charging, but we cannot, unless we measure the time and the voltage by hand and then plot it on some plotting paper, we cannot really see the charge and the discharge. But we can use an oscilloscope. So what an oscilloscope does is it also measures the voltage, but then it plots it on that graph as a function of time. So you can see that there is this line that is running across the screen, and that is the voltage. So you can see this yellow arrow over here marks the 0 point at this stage. There's a slight discrepancy between the two, but we will definitely be able to see the charge and the discharge, so that's not such a concern. It's just also important to note that these vertical lines that run up and down on the screen, they mark divisions which are an indication of time. So at this stage we can set the seconds per division setting, and at this stage it's 1 second. So that means between two vertical lines we've got 1 second of time. And so if we set the seconds per division, we can bring it down a little bit to 0.2 seconds, or we can take it up to 5 seconds, but I'm going to leave it at 1 because 1 is going to give us a good graph. Let me just move this up a little bit. Okay, and that's fine like that. And also the horizontal lines mark voltage. So at this stage it's set to 5 volts per division. That means between two horizontal lines we have 5 volts. And so I am going to connect this capacitor to the voltage source, and then I'm going to charge it, and I'm going to keep the camera on the multimeter and the oscilloscope, and then hopefully we will be able to see how this capacitor charges and discharges. So let me do that. I'm going to keep the camera on these two, and then I'm going to close the circuit, and I'm doing that now. So there you can see that the voltage on the multimeter is jumping, and it's rising dramatically. But there is a bit of a delay on this oscilloscope, so if you can just give it a moment, then you'll see just now how the exponential charge comes. There you can see, there we go. There you can see that there is an exponential charge of the capacitor, and I can pause that graph over there, and there you can quite clearly see how the capacitor is charged. So you can see firstly that the multimeter does not provide an indication of exponential charge. You can simply see that the voltage is increasing, but with an oscilloscope it really is quite clear, and that's a good correlation between the theory that we have learned thus far and a little bit of an experiment. Unfortunately, without an oscilloscope you cannot do this experiment, and that's why we have this video. So to conclude this, what I'm going to do now is I'm just going to discharge the capacitor, and then we can see if we can see the discharge curve, which is also supposed to be exponential in nature. If I can just get this block off over here. Right, so we're going to close the circuit, close it over there. So we're effectively just completing the loop so that the charge can flow. And let me just keep okay, so what's happened now is there we go. There we're measuring voltage again. Our connection point was disconnected, and I'm going to keep the camera on the voltage again, and then I'm going to close the circuit again so that we can see the discharge. Let me just unpause this oscilloscope over here, and there it shows us the charge graph again. Runs it from the side, and let me just wait for that to move off the screen, and there we go. So let us discharge this graph, and there you can see on the multimeter again the voltage is falling quite dramatically, and there's a bit of a step there on the oscilloscope which is unexpected, but there, so the capacitor is almost fully discharged, and I'm just going to focus on the oscilloscope over here, and there we can see there the voltage starts to drop, so there we can really clearly see that there's an exponential discharge curve as well. So we can see that by using an oscilloscope, let's pause that again, there is a method for measuring the exponential charge and discharge of a capacitor as well.